Hello again. So I'm going to solve another of these problems. Might as well do all of them while we're at it. So we're trying to, again, find the stationary points and classify them. So by stationary point, we again mean the local extrema and the IP. Local extrema and inflection point. All right, so the first thing, again, is those points always happen when we do the first derivative test. So I'm going to start using the short form first derivative test, which means I first need to take the first derivative. So the first derivative of this thing here is actually pretty simple. Again, just using the power rule for the first one, you get x to the power of 2. And then the minus x would simply become a minus 1. Now you want to find out when this derivative is equal to 0 because that's when your stationary points happen. This happens to be factoring very nicely, giving us 2 stationary points. So my stationary points will happen when x equals to +1 and -1. Now, the next part is to find our second derivative to be able to figure out if these points are concave up or down, which would indicate that we have local mins or max, or if it's equal to 0, then we have an inflection point. So let's do the second derivative test. So we're going to have f prime prime of x. Again, I'm always using this first form here just because it's so much more simple to deal with. Therefore, we get the derivative of x squared is 2x. The derivative of 1, just like any number, is 0. So that would be your second derivative. And now I would do my number line to figure out what this is equal to. First one is -1. Second one is +1. And we need to... All right. So what is my first derivative at each of these? Again, first derivative is always just 0. No problem there. And then the second derivative is where things get interesting. So what is it at -1? So again, I don't usually write it just because it's mostly very evident. So if you sub in -1 inside the second derivative, clearly 2 times -1 is -2. This is negative, so minus sign here. And then if you plug in +1, you get 2. So this is positive. Very nice, which means here we get, so if the second derivative is negative, it means it's concave down. If it is concave down, it's like a sad face. So this is my function, right? My function is going to look like this because of the first and second derivatives. And this one here is positive, so we have a happy face. There we go. So if we have this here, clearly this is a max and this is a min, which means that for my answer, we have that. That's not what I meant to do. So we get x equals to -1 is a local maximum, and x equals to +1 is a local minimum. There we go. That's it.